Hi, this is John Harlock, QC Pole Instruction. Welcome back. Recently, another instructor asked me how I explain the energy transfer between the cue ball and an object ball. Wow, this is somewhat complex. Physicists and mathematicians have been using pool balls as an example of an elastic collision for years. Now, an elastic collision is where there's a conservation of energy and a conservation of momentum. Now, the equation is quite complex, but what it's saying is that the amount of energy that gets transferred to the object ball is based on the cut angle. And 100% of the energy is going to be used. Some of it going to the object ball, and the rest stays with the cue ball. Now, with that in mind, I've come up with a theory that you can actually use at the table. And that is the amount of energy that's transferred to the object ball is directly proportional to the cue ball overlap. I'll use the following chart of the 3-ball cut system as an example.
The 3-cut system is based on the 15, 30, and 45 degree cut angles. The 15-degree cut angle is made using a 3/4 ball overlap between the cue ball and the object ball. The 3/4 ball overlap results in 3/4, or 75%, of the cue ball energy being transferred to the object ball. The remaining 25% stays with the cue ball. The 30-degree cut angle is made with a half-ball overlap. With a half-ball overlap, the energy is evenly split. Half, or 50%, goes to the object ball. The other half stays with the cue ball. The 45-degree cut angle is made using a 1/4 ball overlap. With a 1/4 ball hit, only 25% of the energy goes to the object ball. 75% remains with the cue ball.
Now that we've been able to quantify the fractional energy that's transferred between the cue ball and the object ball, we need to be able to estimate the energy that the cue ball has. Now, to do that, we need to know what energy is. Now, when the cue hits the cue ball, we transfer kinetic energy to the cue ball. Now, the formula for kinetic energy is 1/2 the mass times the velocity squared. That formula is great in physics. The key concept is that there's two components, mass and velocity. Now, the mass of the cue ball remains the same. It doesn't change. The only thing that we have control over is the velocity of the cue ball. And the velocity is governed by how hard we strike the cue ball. The units for velocity or speed is usually something like miles per hour. Great if you're driving a car, but of little value when shooting pool. There are two of my favorite instructors, Dominic Esposito, the drill instructor, and Jeremiah Gage, author of Bullseye, use a different measurement for the energy of the cue ball. They use the distance the cue ball travels as a measure of the energy. Now, both have different numbering systems for it, but the basic unit of measure for both is a diamond traveled. Example, a 16 diamond shot using Dominic Esposito's system would be a 4-speed. And in Jeremiah Gage's system, it would be a 2-speed. But both are based on 16 diamonds. I'm going to use a 16 diamond speed during the exercises in this video. Before I do that, I need to be able to develop a muscle memory so I can repeat a 16 diamond shot consistently. To do that, I use the following exercise. I place a target on the head string. I then put the cue ball in the center of the target and hit the cue ball so it travels to the foot rail, back to the head rail, and back on the center of the target. I do that repeatedly until I can develop that muscle memory so that I can get a consistent 16 diamond stroke.
This is what the exercise looks like.
Now that I practiced that 16 diamond shot and I can repeat it consistently, I'm going to set up what I call a theory to practice exercise. I'm going to set up a spot shot with the cue ball on the head string. This is going to be a half ball hit. So on contact, half of the energy should go to the object ball, and the remaining half of the energy should stay with the cue ball. Now, it's going to take 4 units of energy, or 4 diamonds of energy, just to reach the object ball. Starting out with 16 diamonds means that when I reach the object ball, there's going to be 12 diamonds of energy left. 6 of those diamonds will go to sinking the object ball. The other 6 will remain with the cue ball. The cue ball should go to the foot rail, 2 diamonds, and come off the foot rail, 4 diamonds, and end up in the middle of the table. Let's give it a try. For the second theory to practice exercise, I'm going to set up another spot shot. But this time I'm going to put the cue ball on the head string in the center of the table. This will set up a quarter ball hit on the object ball. Again, the cue ball will travel 4 diamonds just to get to the object ball. But this time, only 25% of the energy will go to the object ball, which is 3 diamonds. The remaining 9 diamonds will remain with the cue ball. Now the pattern that the cue ball takes will be different than the first, but it should still travel 9 diamonds. 2 diamonds to the head rail, and it'll come off the head rail, and it should come down about 7 diamonds to the opposite end of the table. Let's give it a try. Both these exercises, the cue ball landed pretty much where I expected it to. Now, knowing the direction of the shot and how far the cue ball is going to travel, you'll be able to position the cue ball pretty much anywhere on the table that you want. I also recommend you purchase the books Bullseye by Jeremiah Gage and The Last 2 Balls by Dominic Esposito, the drill instructor. Both of these books have plenty of exercises on positioning the cue ball. Have a terrific day.